Y is the professional sports team in the city of X, where X could be any city that has a professional sports team. Is that a function? If I gave you a particular city, would everybody name the same professional sports team? And the answer is probably not. For example, if I said Atlanta, X is Atlanta, you'd have to name a professional sports team in Atlanta. Some people might say the Braves. Others would say the Falcons. Someone else could say the Hawks, because there is a professional baseball, football, and basketball team in Atlanta. Now, that is not a function, because even if Atlanta was the only example, there is one example where I give you an X, not everybody gets the same Y. There's more than one item of output for an item of input. What if I limited that to professional baseball teams? That is, Y is the name of a major league baseball team in the city of X. Is that a function? Well, Atlanta, hey, Braves. St. Louis, Cardinals. San Francisco, Giants. Cleveland, Indians. Looks like a function, right? Wrong. Because what if I said New York? Or what if I said Chicago? Everybody wouldn't get the same answer. That is not a function. Could I make it a function? Yes, I could. If I said Y is the name of a major league, American League, professional baseball team in the city of X, now there's no problem. As long as the only items of input were those cities that had American League, major league professional teams. For example, Cleveland would be the Indians, Chicago, the White Sox, New York, the Yankees, etc. So that's a good example of a function. Let me give you another example of a function situation. How about Y is the capital city of X? Y is the capital city of X, where X is some state, and the output is the capital city of that state. Is that a function? Think about it for a second. If it is a function, that means for every state there is one capital. If it's not a function, that means there must be a state that has either no capital or more than one capital city. As far as I know, among the 50 states in the United States, each state has one and only one capital. That is a function. Now, you might not know all the capital cities, but you could always look it up in an almanac, and if you had that information, you realize that Y equals the capital city of the state of X is indeed a function. Later on in this lesson, we're going to look at inverses. Inverse is just the opposite. So the inverse function for Y is the capital city of the state of X would be that Y is the state whose capital city is X. Is that a function, by the way? Because that would not be a function if there were two states that had the same name capital city. For example, what's the capital city of South Carolina? It's Columbia. But let's say they changed that, and they made the capital city of South Carolina Charleston, South Carolina. And of course, there is a major city called Charleston, South Carolina. And now I said, Y is the state whose capital city is X, and X was Charleston. Would there be only one answer? And the answer is no, because we'd say the answer could be South Carolina, or the answer could be West Virginia. In that situation, it's not a function. But since Charleston, South Carolina is not a capital city, Y is the state whose capital city is X is a function, because each capital city in this country has a different name than the other capital cities. Okay? And of course, in that particular case, we could say the inverse is also a function. And we'll talk more about this later on in this lesson. Another example. Y is the biological mother of X. X being a person. Could be you, me, anybody else you know. If I give you a person's name, assuming you know who that person's biological mother was, does a person have more than one biological mother? I certainly don't think so. So therefore, that would be a function. And notice I emphasize biological mother, because what if I had said, is the mother of? You say, well, there's a biological mother, there could be a stepmother, and it could be confusing. In functions, you must be very, very specific. By the way, what would be the inverse of Y is the mother of X? That would be Y is the child whose mother is X. Is that a function? If I give you the name of somebody's mother, is there only one possible answer for the child of that woman? In some cases, yes. But for example, I have two brothers. And therefore, if you said my mother's name as X, Y could be me or either of my two brothers. That would not be a function. So there's an example of when you take the inverse, you don't get a function. It's a relation, because if you know my mother, you know her three sons, you can get the answers. But there's not just one answer. So again, a function is a relation in which for every item of input, for every value of X, you only get one value of Y. Let me show you something over here at the easel that can confuse some people. Sometimes we write Y is a function of X. The symbology F of X. General kind of thing. Sometimes we write, for example, Y equals 3X plus 7. Other times you write F of X equals 3X plus 7. These two things are identical. Just different ways of writing the same idea. That Y is a function of X. This says, if I know X, I can find Y. This says, if I know X, I can find the value of the function. We use Y sometimes to represent that. It doesn't make a difference. If you see this, and I say F of X, and you say, wait a second, that's Y. Same thing. If you see F of X, and I say Y equals, same thing. Don't be confused. Just two ways of writing the idea that if I know X, I can find the value Y, or the value F of X. Okay? So I think now we've gotten into what a function is. We need to look at some ideas about a function. The first thing we want to look at is a name we give to the set of input. All the numbers, or in the case of the professional sports teams, all the cities. In the case of Y is the mother of the child X. All the children. That set of all the things we're going to put in, all the values of X, is called the domain. So if you look at the next visual, we could see we have this, what I call a potato diagram, because it kind of looks like a potato. And this potato, or this set, contains the domain of some function. And that domain has, let's see, it has 5 numbers in it. -3, -2, 0, 1, and 4. And you can see inside the potato diagram, there are those 5 numbers. We also have in brackets that the domain is equal to those 5 numbers. The set of those 5 numbers, each number is separated by a comma. Notice also that I've labeled that potato diagram with a script D, a symbol that's generally used for domain. So the domain is the input. Well, if we have input, we also have to have output. And the next visual shows us the output for this function. Notice to the right of our domain is another potato diagram with different numbers, because this is the range. That is, the range contains 0, 1, 4, 9, and 16. That is shown inside the diagram for the range with the script R beneath it to show this is the range. It's also shown as a set of numbers, each number separated by a comma, 0, 1, 4, 9, and 16. So we have a domain, we have a range. When we get the domain and match it up to the range, that is our function. That is our relation. So let's look at the next visual, which shows us on top of the potato diagrams, there's a letter F with an arrow pointing from left to right. F stands for function. The function goes from the domain to the range. And you'll notice that each number in the domain is connected to a number in the range. That is, if we start at -3, the function of -3 is 9. The function of -2 is 4. The function of 0 is 0. The function of 1 is 1. The function of 4 is 16. By the way, can you guess a rule that I used to get the answers, to get the items? in the range. That is, how did I go from -3 to 9? How did I go from 1 to 1? I did the same thing to all 5 members of the domain to get their matching number in the range. Do you know? What I did is I squared the number. I squared -3, that is -3 times itself is 9. I squared 1 to get 1. I squared 4 to get 16. Also notice at the top of the visual, their word function equals, and then in the brackets, there are now ordered pairs, each one in parentheses, and the parentheses separated by a comma, so that we have 5 members of the function. The function is made up of 5 ordered pairs. Again, the ordered pair means the x, or input, or domain number comes first, then a comma, then the output, or the range value, or the y value, that is what is related to the x. So we have -3 comma 9 is one member of the function. -2, 4 is another member of the function. 0, 0, 1, 1, and 4, 16. So you can see there are various ways of